Hello all. Today I am going to represent my paper Enhanced DSSM Deep Semantic Structure Modeling Technique for Job Recommendation. Uh, my presentation outline includes introduction, motivation, literature survey and problem statement, tools and data set, result validation and some references. Now first of all we have to just give brief introduction about recommender systems requirement. We all know social media generate enormous amount of data through sensor data, mobile, social media, demographic, healthcare and e-commerce. So this leads to various issues in that. So one of the issues will be information overload, privacy and bandwidth problem. So all this data will be not helpful for further information. So that's why we require some filtering system that will select only fascinating information and reject other information. So recommender system is a viable solution for all. But existing recommender system have different problem. For example, scalability issue, cold start problem, as well as different attack problem and sparsity. So we have to solve this problem by using new graph algorithm as well as new word embedding algorithm. Today I am going to take an introduction about job recommendation. So in that, job recommendation will be what very important for recruiter as well as job seekers point of views. But as we observe in 2021, unemployment ratio was suddenly fall because of a great lockdown, and that will be what increased by 13.8%. So that's why a fascinating job recommendation system required that will provide a better candidate selection, cold start problem, and again database modularity problem can also be solved. So that's why in job domain we require some skill embedding as well as graph embedding algorithm that will represent that things. So to this motivation we have to implement a algorithm that solve complex query problem and generate matching algorithm that match potential candidates detail for job opening. Again it also solve bias as well as skew problem of different data set. So for this purpose we refer many various papers, but in that here we listed 7 to 9 paper that includes job recommendation introduction as well as existing word embedding algorithm as well as deep semantic structure modeling algorithm. Based on this literature survey we drawn some conclusions, so that is what we have to require deep learning methods. So deep learning method will what effectively improve the recommendation accuracy, and again it handle scalability issue also. So for this deep learning method, we require text classification. So existing text classification techniques include feed forward model, that is work on text based approach. Second will be RNN, recurrent neural network, that work on sequence of words, and again CNN, that is a convolution network, and it will be what phrases as well as for classification. Capsule model also introduces the problem of CNN, and again very important attention mechanism that identify the correlated word useful in that system. After attention model, memory model as well as transformer will be what giving more insight that provide more parallelism than RNN model. After RNN and transformer, we have a graph model that will give better word embedding techniques in natural language processing. So with the help of this text classification, we had to resolve cold start problem as well as data sparsity issue better than existing approach. As for this analysis, we divided this research, deep learning research, in 3 different categorization. First categorization will be based on this RNN model. So it started in 2014 and it leads 2015. So basic RNN and vanilla RNN will be what in 2014, and again modified RNN will be what LSTM as well as MLSTM that will solve the what different problem of word long sequences as well as what previous parallelism. So this in 2016 and 17 again topic based RNN and by LSTM model also introduced. So that is a second category LSTM model we have to use. But again this LSTM model only improve the performance, but word handling capacity cannot be increased. So 2018 and 19 we refer text CNN as well as improved by LSTM model. That model also gives some immense exposure, but in 2019 a new model DSSM along with 2 DSSM as well as CDSSM will be introduced that uses what word hashing techniques, and it also handle large vocabulary, and again it will be provide a better semantic structure modeling in that. So our proposed DSSM algorithm for scalable graph model, scalable job model that include different steps here. It required input data set that carried job title as well as skills, and after that it will compute word hashing. That word hashing is what again our proposed DSSM. In that it generates trigram of that. It also includes the term vector. That term vector we have to again provide hashed input vector, and again multi-layer process term will be generated their different layers, and again final output layer will be what give in the form of rank prominent skill. So this is a proposed DSSM model. So mathematical structure in that what we have used input vector in the 500k, and again hashed input vector should be what 30k, and then again my MLP layer should be what I1 and I2, that should be what 300k. So my mathematical model at end provide a ranking and learning based on this, and that will be what a major implementation of this. So this is my complete mathematical model of proposed DSSM model. Here we have using a text vector X, word I'm missing layer here, and again multi-layer perceptron that will generate here, and again semantic feature that will be combined, and at the end what document and query will be generated. For this analysis we have used different tools and data sets. For this we have referred Python, Jupyter Notebook, TensorFlow and Keras. And again my data set should be what Career Builder data set, listing data set, Naukri.com data set, and again very important Niti Aayog's Unnati portal data set. In that all data set we executed and evaluated the performance. To all these things we have to generate a problem statement. Here my search query are used as a query and document pair, which consisting of search criteria such as the job title, skill and location from the recruiter data set. And the goal of my model is what is to select the prominent skill and rank the candidate based on the what graph recommendation approach. For this implementation, for this analysis, we had set some experiments. So in that what for experimental purpose, we refer PySpark, and again we also do some quantitative and qualitative experiment that verify the effectiveness of the model. And again we use some different measures, metrics, for example precision, recall, app score, that will provide a better accuracy, as well as we have to measure accuracy. As we observe, my word hashing is the first layer of my proposed DSSM. So the word hashing will be what generate term frequency in the terms of diagram. So here word hashing diagram frequencies data for these two documents D1 and D2 will be generated. Second, my MLP layer, non-linear activation layer, will be what? It is suitable for categorical data set, and in this what it provide different uh, different layer of that added bias also B0, B1 and B2, and at the end what? It compute this similarity score. So finally this multiple layer perceptron and non-linear function will generate objective functions, and it will again produce the ranked skill. For this experimental purpose, we have to refer some basic embedding model, that is a bag of word, a continuous bag of word LDA, and term frequency and inverse term frequency with features. And again we evaluated their precision and recall on this categorization. Here we consider 10% of job data, and again we provide k value 10 to 30. So 10 to 30% of job data we have to refer here for computation of this precision and recall. As we observe here, TF-IDF with contextual feature will give out better result in precision as well as in recall. Again my second experimental source here, I am referring TF-IDF with contextual feature, and again doc to vector approach, and again doc to vector with contextual feature, and with this same experiment setup. As we observe here, this precision and recall value is automatically increases. So as we observe here, doc to vector will be what a better model as compared to other. So this graph and this experiment will be what shows here complete runtime performance on sample data set. As we observe here, this doc to vector with contextual feature will took 87 milliseconds time on 500 different sample job. So that's why as we observe here, this will what increases the what accuracy of system. But again if my job will be what increases, so that time what this doctor vector will be what not a viable solution. So that's why here we proposed EDSSM model that handle more than 500 or 5 million job at particular instance, and again it provided prominent skill. So proposed EDSSM model will give a better runtime performance as compared to existing. So as we observe in graph, here we compare proposed EDSSM model with matrix factorization and graph based approach. As we observe here, our model will give better result as compared to other model. As we observe here, proposed DSSM model also we had to execute it their similarity with different setup in supervised and unsupervised embedding. In unsupervised embedding, we considered here dot and head element similarity and we computed their precision recall, precision in 1, 5 and 10% of data. And we observe here their runtime performance here. So as we observe here, models should having a XGBoost we are using for their performance evaluation, skill and job title multi-dimensional data set we have to use here, and again in supervised embedding here we used text of different dimensions. As we observe here in DSSM advanced enhanced DSSM with supervised and unsupervised embedding will what provide a better prominent job as well as skill diagram as compared to existing system. So this is what existing systems plot with as compared to my EDSSM model. So as we also observe here, we have to validate our result on carrier builder data set. That data set size is already discussed here. We observe here, enhanced DSSM model will give 94.9% precision, 92.5% recall, and again 94% runtime and 92.9% accuracy. As we observe, this will what increases the performance, but existing job model what decreases performance when the number of job increases. So this is what a viable solution. As we observe, with the help of this EDSSM model, we have to gain some performance improvement. So as we observe here, 2% of performance improvement and again 0.2% of what? Total p-value here improvement we require. So total precision will be what here? 3% and total performance improvement will be what? 2.5%. So again I compared this result to contemporary researcher with DSSM model, CDSSM model and 2-arm DSSM model. We observe here proposed DSSM model will be what give better result as compared to existing model. So these are my graph existing proposed DSSM algorithm with job title and skill similarity here. Again second variation of this proposed CDSSM algorithm that will use as a convolution. So here if you have a maximum skills and maximum title, so that time what CDSSM will be applicable. And again 2-arm DSSM will be what helpful in different layers if our data is distributed in different places, so that time what this will be what better solution for that. So here we executed these three proposed algorithm and DSSM, CDSSM and 2-arm DSSM, and we measured their precision, recall, runtime, MSE error as well as accuracy. As we observe here, it gives better precision and accuracy on centralized as well as what in distributed data set. So I am concluding here my paper, my research work, enhanced DSSM will what solve cold start problem scalability, and again it help in different application. As we observe here, this novel algorithm will be what to provide better solution to handle cold start, and again system can be used in scalable, centralized as well as in distributed environment. So production time and cost of installation will be what reduce. Again the system will be applicable in talent herd system as well as is also used in a small recruitment domain where rural and urban area where skills and jobs are not so big and not so contemporary. This is also applicable in search engine where search and match is important criteria. Scope of my research is this was we had to use in this other than this job domain, we had to use in amazon.com and again shadi.com and again in important in search engine where we have to use in search criteria. Again for performance improvement we can use this system in public as well as in private domain also data. So here a geographic location for job search also we have to consider, so then performance will be improved. As we also observe here, we consider here missing value, feature selection, high dimensionality, large scale and score for the result. As we observe here, our system will provide better in all data set. So I am here acknowledging my professor as well as family friend. So I thanks to my guide Dr. Seetal Rathi madam. She always give me good ideas and good motivation to do further. Again I also thanks to my family member and my friend, and again my colleagues also who always support and help me in our situation. I thanks to Thakur College of Engineering and Technology for giving me best infrastructure and practical implementation and lab support and admin support. For this research, I referred many research papers so that are listed here. And again, these are my research papers. I published this research in elsewhere journal, and again I filed patent also. So this is my research contribution. So thank you for your kind attention. If you have any query, any doubt, you can reach me at the ravita.mishra@vs.ac.in. Thank you.